Decision properties of regular languages is nothing but any decision problem is look like this. We have a problem solver machine, that is it might be DFA, NFA or PDA, push down automata or Turing machine. Generally given input for this decision property, the decision will be say in terms of yes or no or accept or reject. So now we'll see what is a membership questions decision problem. So membership questions will be, you have to decide it whether the string is accepted or question as given in this. So with the terms of decision problem, the given L is a nothing but is a language. It should be exist in L. That means it is a W. W. So is W in L, whatever the language is it generate, whatever the language has given, whatever the string is generated by L, is it in L, that is W. Possible answer is yes or no. The approach how to solve this decision problem, either you have to go by these three approach. One, by building a DFA for L. So suppose already you seen this building a DFA. So you will take the language, then you construct a DFA whether it is accepting a given L, given strings. Then input WR to the DFA. If the DFA ends in accepting state, then yes, otherwise no. So there is one more test is called emptiness test. What do you mean by emptiness test? It is also comes under the decision problem. So is L is equal to pi. So what is pi? Already we have seen that is a pi is an empty. So empty, there is no transition at all. How to test it? Again, here is one approach is called on DFA for L. From the start state, run a reachable test which returns. So then it is you have to test it on the start state and it runs reachability test which returns a success if there is at least one final state that is reachable from the start state. So when do you say it is a reachable emptiness test? So if there is at least one final state could be reachable from the start state, then it is say success. Otherwise you can say failure. So similarly, L is equal to 5 if and only if the reachable test fails, that is means L is emptiness, that means it will not reach to any accessible state. Finiteness, what do you mean by decision problem? Is L is finite or infinite? Approach could be on DFA. So what are the tests that it could be do? Remove all states unreachable from the start state, or remove all state that cannot be lead to any accepting state. After removal all, check for cycle in the resulting FA. If cycle is resulting it, L is finite. If there are no cycles, otherwise it is infinite. L is a finite if there are no cycles. Otherwise it is a infinite. If it is a FA as cycle, then it can say it is a infinite. Okay. Another approach you could go with that to test it, build a regular expression, look for the clean closure. Okay. So how to implement step 2 and step 3, you have to go by this. Is the language of this DFA finite or infinite? So you have to test with the finiteness test. So whether the DFA is accepting finite number of language or finite language or infinite language. Look at the test, it is here. These two are showing is a finite. So Q6 and Q5 are a finite. How do you say that is a finite? Then this is not, this is due to this is a infinite, is a infinite. Why that is infinite? Because the Q3 is rotating there itself. It's a reachable and dested. This is a dested, you can remove it and remove one of the dested. This is a dested, this is a dested. If I remove it, there is no cycle in that. If there is no cycle in this, there is no cycle, then as you can say finite. So finite. So these two are red mark showing it is a dead state. So Q5 is a dead state and Q6 is a unreachable state. Then you can remove them. Then you have to find it is there in is a cycle. Absolutely there is no cycle. Then you can accepting finite language. You see other one, is the language of this DFA finite or infinite? Definitely, if I after removing Q5, then I have to check is it a have any loop. Definitely Q3 has a loop. It accepting any number of zeros and ones, then you can say it is a infinite. With this, I'm winding up a pre-video, right, of this pre-video of this topic. Then let us meet in the next pre-video. Thank you guys.